Hey everyone, welcome back to the channel. Today we're breaking down two of the most talked about tools in the Python data world, Pandas and PySpark. If you've ever typed import pandas as PD, you already know pandas. But the moment your dataset gets too big for your laptop, people start throwing around this other name, PySpark. So what actually is it? How is it different from pandas? And when should you reach for one over the other? By the end of this video, you'll know exactly which one to use for your next project, and I'll walk you through real code for both side by side so you can follow along. Let's get into it. Here's the plan. First, I'll explain what PySpark actually is and what Pandas is in plain English. Then we'll look under the hood at how each one actually processes your data. This is where the real difference lives. After that, a head-to-head comparison table, a quick look at performance, and a decision guide so you know exactly when to use which one. And finally, we'll get hands-on with a live coding walkthrough. Let's start with PySpark. PySpark is the Python API for Apache Spark. Spark itself is an open-source engine, originally written in Scala, designed to process huge datasets by spreading the work across many machines at the same time. PySpark just lets you write that same distributed logic using Python. Syntax you already know. Here's the key idea. Instead of one computer doing all the work, Spark uses a cluster, a group of machines working together. Look at this diagram. You've got a driver program. Think of it as the project manager. And it splits the job into small tasks and hands them out to multiple worker nodes. Each worker only processes its own slice of the data in parallel at the same time as all the others. That's the whole trick. If you've got a 500 gigabyte dataset and 10 workers, each one might only need to chew through 50 gigabytes. That's what lets Spark scale to terabytes, even petabytes of data where a single machine simply can't keep up. And it's not just batch data processing. PySpark also handles streaming, data, SQL queries, and even machine learning at scale, all through the same API. Pandas is Python's most popular data analysis library, and it's built around one core structure, the DataFrame, basically a table with rows and columns that lives entirely in your computer's memory. Notice the contrast with the last slide. There's no cluster here. Pandas runs on one machine and by default on a single CPU core. When you load a CSV file with pd read_CSV, the entire file gets pulled into RAM before you can do anything with it. That's exactly why Pandas is so fast for small and medium datasets. There's no coordination overhead, no network calls between machines, just your computer doing the work directly in memory. But it's also the catch. If your dataset is bigger than your available RAM, Pandas doesn't gracefully slow down. It either grinds to a crawl, swapping memory to disk, or it just crashes with a memory error. That one limitation is basically the entire reason PySpark exists. This slide is the one I want you to really pay attention to because this is the conceptual difference that trips people up the most. On the left, Pandas is what we call eager. Every single line of code you write executes immediately. You load the CSV, that runs right now. You filter rows, that runs right now too, and the entire filtered result sits in memory before you move to the next line. On the right, PySpark is lazy. When you write .filter or .groupby, in PySpark, nothing actually happens yet. Spark just adds that step to an internal plan. It's only when you call what's known as an action like .show, .collect, or writing the output to a file that Spark finally looks at your entire plan, runs an optimizer called Catalyst to figure out the smartest way to execute it, and then splits the work into tasks and runs them across your executors. Why does this matter? Because Spark can be smarter about how it runs your code when it can see the whole plan at once, instead of executing blindly. Line by line, it can skip unnecessary work, reorder steps, and combine operations. Optimizations Pandas simply can't do because it's already executed each line before it even knows what you'll ask for next. Let's put it all in one table so it's crystal clear. Data size. Pandas is happiest with data that fits in RAM, megabytes up to a few gigabytes. PySpark is built to scale from gigabytes into terabytes and petabytes. Asterisk. Execution. Pandas is eager, PySpark is lazy. We just covered that. Processing. Pandas runs on a single machine and, by default, a single core. PySpark distributes work across many machines and many cores at once. On big data, Pandas slows down or crashes, while Spark is built exactly for that scenario and stays fast. But flip it around on small data, Pandas is actually faster because PySpark has cluster and planning overhead that just isn't worth paying for a small file. Setup is another big one. Pandas is a pip install away and works instantly. PySpark needs a proper environment, Java installed, and ideally an actual Spark or cluster setup. And one more thing people forget, fault tolerance. If a node in a Pandas job, well, there's only one node. If it crashes, you lose everything. If a worker in a Spark cluster crashes, Spark automatically recomputes just the lost piece of work and keeps going. Let's visualize that trade-off with some illustrative numbers for a simple aggregation task. At 1 gigabyte, Pandas finishes in about 3 seconds. PySpark takes around 9 because it has to spin up its execution plan and cluster coordination. First, Pandas wins here. At 10 gigabytes, they're getting closer. 40 seconds for Pandas versus 22. For Spark, Spark's already pulling ahead. At 50 gigabytes, it's not close anymore. Pandas takes 210 seconds more than 3.5 minutes, while Spark finishes in under a minute. And at 200 gigabytes, notice there's no bar for Pandas at all. That's not a mistake. On most machines, a dataset that size simply won't fit in memory, so there's no number to show. PySpark, meanwhile, handles it in about 2.5 minutes. The takeaway: it's not that one tool is faster than the other in general, it's about where your data falls on this curve. Okay, let's actually look at code because I know that's what a lot of you are here for. On the left, Pandas. 3 lines to import the library, read a CSV, and you're already working with a DataFrame. On the right, PySpark. Notice the extra step. We have to create something called a Spark session first. This is your entry point in a Spark. It's the object that manages the connection to the cluster. Pandas has no equivalent because there's no cluster to connect to. After that, the syntax actually looks pretty familiar. Spark.read.csv instead of pd read_csv and .filter instead of that df condition. Bracket syntax. If you already know Pandas, PySpark's DataFrame API will feel surprisingly familiar. One small but important detail. Notice PySpark's read call has infer schema equals true. Spark doesn't automatically guess column types the way Pandas does by default. You either specify the schema yourself or ask Spark to infer it, which does cost a little extra time on large files. So, practically speaking, when should you actually reach for each? 1. Use Pandas when your data comfortably fits in memory, so we're talking up to a few gigabytes on most machines. Use it when you're doing fast, exploratory analysis, prototyping an idea, or you need Pandas' huge ecosystem of plotting and statistics tools. And obviously, if you're working solo on a laptop with no cluster available, Pandas is your only realistic option anyway. Use PySpark when your data is too big for one machine. We're talking gigabytes into petabytes. Use it when you need real distributed processing, when you're building production ETL pipelines that need to run reliably every day, when you need fault tolerance so a single node crash doesn't kill your job, or when you also need streaming data or machine learning at scale. And here's something worth remembering. These tools aren't rivals. A very common real-world pattern is prototyping your logic in Pandas on a small sample of the data because it's fast to iterate, and then porting that same logic to PySpark once you're ready to run it on the full dataset in production. All right, enough theory. Let's actually run some code. I'm going to walk through the exact same task in both libraries. Load a small sales dataset, filter it, group and aggregate it, and compare the output. Asterisk. For steps, install both libraries, load the data, transform it, and compare what we get back. Shell command from a cell. One thing to flag. PySpark needs Java under the hood, specifically Java 8, 11, or 17. The good news is Collab already ships with Java installed, so this Java version check should just work out of the box. No extra setup needed like you'd have on a fresh laptop. Step 2. Create and examine the sample CSV data. Now, let's create a sample CSV file. I already have one prepared. Let me show it to you and take a look at the sample data. Let's start with Pandas. Import the library, read the CSV, print it. 3 lines. And there it is instantly. The entire file just got loaded into memory and printed. No waiting, nothing else needed. And notice no install step either, since Pandas ships with Collab by default. Now the same thing in PySpark. Notice the extra step right away. We have to build a Spark session first. App name is just a label for this job. And get or create either grabs an existing session or spins up a new one. This is Spark's entry point. Pandas has no equivalent because there's no cluster to connect to. Even here in Collab, running on a single machine, Spark still spins up its whole engine underneath. Notice that took a beat longer to start than Pandas did. That's the Spark engine initializing behind the scenes. And here's the schema it detected. Notice amount came through as an integer automatically, because we set in first schema equals true. Without that flag, Spark would treat every column as plain text by default. Let's wrap up with the 5 things I want you to remember. 1. Same language. Both are Python, so the skills and thinking you build in one genuinely transfer to the other. 2. Different scale. Pandas is bounded by one machine's RAM. PySpark scales across an entire cluster. 3. Different timing. Pandas runs eagerly, line by line. PySpark builds a lazy plan and only executes when you ask for a result. For a different job, Pandas shines for exploration and analysis. PySpark shines for production, big data pipelines. And 5. They are not rivals. Plenty of real teams prototype in Pandas on a sample of their data, then port that exact logic to PySpark once it's time to run at full scale. That's PySpark versus Pandas. My honest advice: if you're just starting out, learn Pandas first. The concepts map directly onto PySpark later, and you'll understand why Spark's distributed model matters so much. More once you've felt Pandas' single machine limit for yourself. If this helped you, drop a like, subscribe for more data engineering content, and let me know in the comments, are you Team Pandas or Team PySpark? I'll see you in the next one.